Hello guys, good morning. You are welcome to my YouTube channel, the SPC Tutorials. As you all know, my name is Dr. Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment so that when I upload a new content, you'll be notified by YouTube. We are still discussing circular motion and gravitation in physics. The first part has been treated by God's grace, and today we'll be taking the other part before we jump into more calculations. If you know you haven't watched the first part of the video, I will advise you to do so to have an in-depth understanding of the topic. Alright, so please take note of that. So in today's video, we shall be looking at the other part of the topic. Alright, now we'll start with Newton's universal law, Newton's universal law of gravity. Of course, this law is not new to us, it's not new at all. Now, this law states that the force of attraction or repulsion between two masses, m1 and m2, is directly proportional to the product of the masses, and inversely to the square of the distance that separates these two masses apart. I'll take it again. This law states that the force of attraction or repulsion between two masses m1, m2, alright, is directly proportional to the product of these two masses, that is m1 times m2, and inversely to the square of the distance that separates these two masses apart. Now, if I should eliminate this proportionality sign, I will have to introduce a constant, and that constant is what? G and not K. If I should do that, I'll be having F equals GM ME over what? R squared. Or let me just be specific for now. So M2, M1. G, I said, is called Newton's universal constant. Newton's universal constant. And it has a value of 6.67 times 10 raised to the power minus 11 Newton meter squared per kilogram squared. This is the unit. G stands for, or it has a constant, or it has a value 6.67 times 10 raised to the power minus 11. Then Newton meter squared per kilogram squared. Please don't say n raised to the power 2 slash kg2. No, it's not correct. It's not pronounced that way. So please take note of that. Now I'll call this equation 1. Now we've established that already. However, in terms of the mass of the Earth and the radius of the Earth, I'll change this to be Fg. Fg is equals Gm, that is, I'll use small letter m and big letter me over what? Re squared. Me here connotes what? The mass of the Earth, while Re stands for what? The radius of the Earth. Take note of that. So this equation 2. I believe it's clear enough, isn't it? The next one is weight, gravity, and altitude. What does altitude, whenever you hear the word altitude, what comes to your mind? Height. Now, the weight is defined as the gravitational force of attraction between the Earth and the object in question. It is what? The gravitational force of attraction between the Earth and the object in question. Gravity is that force that pulls down an object towards the Earth, and I said that altitude connotes what? Height or distance, and it's represented as what? Small letter what? H, height. Now take note that as soon as an object leaves the Earth's surface, as soon as an object leaves the Earth's surface, please, the radius becomes RE plus H. If the radius becomes RE plus H, what does that tell you? It means that wherever I see this, I'll put what? This. Alright? It therefore means that FG is equals small letter m, don't forget, ME, open brackets, RE plus H all squared. Isn't that correct? Very, very correct. It is very, very correct. Is that not it? So because R was having squared, so I've introduced it, and now we're having what? RE plus what? H. Because R is what? RE plus H. Take note of that. So I'll call this equation 3. I believe is understood enough. Now, please, can I wrap up this part? I believe you are done with this. For example, if I'm having, let me assume this structure to be the earth. Okay, that's the mass, I'll assume it to be the mass of the earth. Please, big letter M. Mass of the earth, then radius of the earth. Alright, mass of the earth, now have what? Radius of the earth. And here, I'll give it to you as what? The force. And force, you know, is called, you know, that's what? Mg. M what? G. If force is equals mg, please, I'll wrap up this part. If force is equals mg, we've deduced that force is what? Big letter ME over what? Over RE squared. RE squared connotes what? Of course, the radius of the earth. And this is what? Mg. Mg. So this would go into this. Is that not correct? So this will go into this. And now we are having G ME over RE. So this equation what? 3. So which means I've gotten my G here. Oh, you understand what I'm doing. F, this F is this, or to be much more precise, hold on, I'll rub it, let me do something so you understand it better. So I give it that G is ME over RE plus H all squared, right? And this is equals what? Mg. Yes. So if I should cancel out these masses written in small letters, I'll be having what? G M E, right, over RE plus H all squared. Then this is equals what? G equation 3. I believe is clear now, right? So from here, you now know what to do. We are not done with this part. Okay, so from what we've deduced already, we can also, I think, let us introduce satellite motion. Yes, satellite motion. So I'll rub off this part. I believe this is clear enough. So just follow it step by step. You understand it, okay? So I'll rub off this part. Okay, before I go into satellite motion, let me introduce what is called gravitational field strength or gravitational field intensity. Now, gravitational field intensity is expressed as the ratio of force to mass. It is expressed as the ratio of force to what? Mass. If this is expressed as the ratio of force to mass, what does that tell you? I gave you that G M E over what? Arrow, that is arrow squared over what? M, right? Because this M is this very one. So what I have here is what? This F. So from here I'll say G M M E over arrow squared times 1 over what? M times 1 over M. So it means that this M will go into this M. Hope you are following. It means that this M will go into this M. It therefore means that Fg now is equals G mass of the earth over what? Arrow squared. Equation what? 4. If you don't understand what I did here, let me do it again. This is GMME over R squared. You know this sign represents what? It represents division. So divided by what? M. This M over what? 1. If I should introduce times, alright, if I should introduce times, that is M comes down and 1 goes up. That is what I have here. But this can go into this. I'll not be having what? GM over what? R squared. So this expresses gravitational field intensity or strength. Is it clear enough? So the next one is satellite motion. Satellite motion. Satellite motion. What do you understand by the term satellite? Satellite is a man-made apparatus or equipment that is concerned with communication and what? Data. It is concerned with communication and data. It is man-made. It is a man-made apparatus. Take note of that. Now, satellites is actually meant to rotate circularly. It rotates circularly about its what? About its axis. For it to rotate circularly, it means that something must be behind the circular movements of it. So, what do you think keeps it moving circularly? It is what? Gravitational what? Force. It is not directly gravitational force. So I will explain now. For this satellite to move circularly about its axis, the gravitational force produces centripetal force. Produces what? Centripetal force. It is this centripetal force that keeps the object moving circularly. I think we established that centripetal force is that force that is needed by an object to move in a circular manner. Hope you've not forgotten. So please, for the satellite to maintain its circular motion, it means that the gravitational force must produce the centripetal force. Please take note of that. It is very, very important. However, there are some instances or there are some cases where the satellites begin to orbit elliptically. When the satellites begin to orbit elliptically, when the satellite begins to orbit elliptically or elliptically, what will happen? See, there's what we call apogee and perigee. Apogee and what? Perigee. As soon as satellites begin to orbit elliptically, the part of the satellite that is close to the Earth is called perigee. The part of the satellite that is close to the Earth is called what? Perigee. While the part of it that is far from the Earth is called apogee. As now the satellite begins to orbit elliptically, the part of it that is close to the Earth is called perigee, while the one that is far or that is farthest from the Earth is called what? Apogee. Therefore, if a satellite rotates elliptically, please take note, the speed varies. The speed what? Varies. That is, it what? Changes. As the satellite begins to rotate elliptically, the speed changes. It therefore means that the shape of the orbit changes from circular to elliptical. It therefore means that the reason this guy moves elliptically is because of what? Change in what? Velocity, change in speed. To change the shape of the orbit from a circular one to elliptical, what happens? There is a change in what? Velocity. So please take note of that. It is very, very important. Now, if the speed of the satellite varies, what do you think? Do you think it is highest in the perigee or lowest in the apogee? Please, as soon as the satellite rotates or orbits elliptically, please, the highest speed is located in the perigee point, while the lowest velocity is located in the apogee point. So please take note of that. It is very, very important. Now, for satellite to orbit circularly, I told you that the gravitational force must produce the centripetal force. Hope it's recording. Good, it's recording. Now, which means that the both of them, they have a direct relationship. It means that Fg, which is what? Gravitational force, is equal to what? Fc. Don't you agree? Fg stands for what? Gravitational force. Fc stands for what? Centripetal force. I told you that it is gravitational force that produces what? The centripetal force. Now, from what I have here, I told you that Fg is giving us what? G M E over ROE squared, all right, ROE squared, then equals mv squared over what? R. Mv squared over R. Now, why do I have this? This is a formula of what? Centripetal. I'll take the seat down, please. Centripetal what? Force. So from here, it means that we'll cancel out these two guys. I'll now be having G ME over RE squared equals V squared over what? R. Now, I told you that as soon as an object leaves the Earth's surface, the radius changes to what? H RE plus what? H. Or let me just put it this way. Let me write R squared. Now it means that whenever I see arrow, I'll put RE plus what? H. Now, in doing that, I want to make V the subject of the formula, which represents what? The velocity of what? Satellite. But before I impute this, let me simplify this further. In doing this, I'll be having V squared R squared, because I want to cross multiply, equals G MER, right? GMER. If I'm having GMER, what do I do next? We have to make V the subject of the formula. In doing that, I'll have divided by R squared divided by what? R squared. Divided by R squared, I'll be having this going to this, right? I have one arrow, I have two arrows here, and I have what? One arrow. So I can just cancel out one from here. So I'll be left with what? 1. So I'll remove this. I have arrow over arrow squared. 1 is just like saying 1 over arrow times what? Arrow. If this should go into this, you are still left with what? 1 arrow. So you have this, which means that V is equals, these two cross over. As now it crosses over, it becomes, as now it crosses over, it becomes what? You now have G M E over R. So you have okay, this you now have this, then as this divided by this, I'm trying to go through it. Then you have MER, then this divided by this, you have what? This. So divide both sides, you have this. So that is what you have. But we said that arrow is what? Arrow E plus what? H. Arrow E plus H. It therefore means that I'll just remove this arrow, right? I'll write arrow E plus what? H. Alright? So please take note of that. It is very, very important. Now, this is what? The satellite velocity. This is the satellite velocity. What again? Is there another point I have to drop? I don't think so. Let me check. Let me solve questions, please. I think there are some exercises on this textbook. There are some exercises on this textbook. Okay, we have okay, calculate the first, or before I go into it, should I proceed with this? Let me just proceed with this, okay? So we've got to this point. Just follow it step by step. So it means that for satellites to maintain its circular motion, all right, it means that the gravitational force must be equals what? The centripetal force. So please take note of that. Now let me tell you something. I'll rub up this part. There's what we call satellite decay. Satellite decay. Satellite decay. Satellite decay refers to the gradual decrease. It refers to what? The gradual decrease of the orbit of the satellite around a celestial body, which could be moon or what? Sun. I take it again. Satellite decay refers to what? The gradual it refers to gradual decrease in the movement of the satellite about a celestial body. For this to happen, okay, what results to satellite decay? The force that brings about satellite decay is called what? Retardation force. Because of this retardation force, you begin to see some particles or fractions. As soon as particles or fractions begin to emit, what happens? The satellite enters back to the Earth. And as soon as it enters back to the Earth, you can need to what? Burn it, start breaking and what? Burning. So please take note of that. What brings about satellite decay is called what? Retardation force. However, in order to keep it stable, we know that W is equals to what? Mg. Right? W is equals to what? Mg. And we know that force is also equals to what? Mg. Are you following? So if force is equals mg, and I told you that force is g m e over arrow e squared equals what? Mg. What does that mean? It means that this, okay, there's small letter m, so this small letter m going to this one, I'll now be having g m e over what? Arrow squared. That's arrow squared e. Alright, so please, you actually don't need all these derivatives. All you need is the final formula. It is final formula you need in tackling questions on it. Alright, so please take note of that. It is very, very important. What again? What again? What again? What again? Okay, which one again? I think, okay, good. The last one for today is called, orbit period. Orbit period is known as what? Big letter what? C. What is the meaning of orbit period? Orbit period is the ratio of circumference orbits to what? Its velocity. It is the ratio of the circumference orbits to its what? Velocity. And circumference orbit is written as 2 pi r over what? V. 2 pi r over what? V. This is the first approach. But I told you that r is equals what? Re plus h. Re plus h. Re plus h. It therefore, okay, this. Okay, you now have this. It therefore means that t is equals 2 pi, open brackets, re plus what? H. Then over v. Hope you understand what I'm doing right now. So, okay. Is there another part I have to actually drop? Okay. My mind. Okay, square root both sides. Okay, fine. And I told you that v from what's it called? From satellite velocity. I told you that v is equals root g m e over re plus h, right? I believe I said that. Re plus h. So which means whenever I see v, I'll put what? Re plus h. It therefore means that t is equals 2 pi re plus h over what I have here, big roots g m e over what? Re plus what? H. So v is what I have here, and this is the numerator. It continues, we are not done. In order for me to eliminate these roots, what this square root, I will have to what? Square both sides. If I should square both sides, I'll be having squared. Isn't that correct? So I'll now be having t squared. T squared is equals now these two here affect everything inside the bracket. So 2 we go into this square roots. So this 2 times 2 you have what? 4. Then 2 times this pi you have what? Pi squared. Don't forget these two also affect this. You have what? Re plus what? H all squared. Then over what I have here is this divided by this, then divided by this. Let me bring it out.